Let's solve the equation. The square root of 2x plus 9 plus the square root of x plus 5 is equal to 2. Here we have a fairly complicated equation with two radicals in it. Let's begin by isolating one of them. So let's subtract this square root of x plus 5 term from both sides, moving it to the right-hand side. At this point, let's square both sides to eliminate this radical on the left. The square root of 2x plus 9 quantity squared is 2x plus 9. On the right-hand side, don't forget that we need to FOIL this out. As we FOIL, we'll be taking 2 times 2 to get the first term. 2 times 2, let's go ahead and call that 4. Our middle term comes from 2 times the inner and outer product, or a 2 times the first term times the last term. And lastly, as we take the square root of x plus 5 times itself, we get the square root of x plus 5 quantity squared. On the left, let's just rewrite this as 2x plus 9. We'll clean up some terms on the right. With this middle term, let's call that 4 times the square root of x plus 5. And yes, it's negative. With our last term, the square root of x plus 5, quantity squared is x plus 5. Now at this point, we still have a radical in the equation. So let's now isolate it on one side and move everything else away from it. I think I'll, as a next step actually, let me go ahead and combine these two terms. That 4 plus the 5 gives a 9. And don't lose that value of x. Now we'll begin to combine like terms over on the left-hand side. Subtracting x from both sides, 2x minus that x is equal to x. As we subtract 9 from both sides, it disappears. So we're left with the statement x is equal to a negative 4 times the quantity, the square root of the quantity, x plus 5. So our equation looks like this. Let's square both sides again to eliminate that radical. Squaring the left, squaring the right gives x squared is equal to, so we square that negative sign, it's gone. 4 squared is 16, and the square root of x plus 5 quantity squared is x plus 5. Let's distribute. 16 times x is 16x, plus that 16 times 5 is 80. Here we see we have an equation that's a quadratic equation. Let's move everything to one side, set equal to 0 on the other. I'm going to subtract terms over to the left to obtain x squared minus 16x minus 80 is equal to 0. Let's see if we can factor this quadratic equation. If it does factor, it'll factor into two binomials. The leading terms must be x and x. Factors of negative 80 that sum to a negative 16 are a negative 20, positive 4. Using the zero factor property, then x minus 20 is equal to 0, or x plus 4 is equal to 0. Therefore, x is equal to 20, or x is equal to negative 4. These are our possible solutions. But because we've squared both sides of the equation, twice even, let's make sure that we check those to ensure that we haven't produced any extraneous solutions. As we check, we want to check into our original equation, which was the square root of 2x plus 9 plus the square root of x plus 5 is equal to 2. Let's first check the possible solution of x equal 20. Substituting that into x, 2 times 20 plus 9 under the first radical plus the square root of a 20 plus 5. Is that equal to 2? Under this first radical, we have the square root of 2 times 20 is 40 plus 9, or 49, plus the square root of 25. The square root of 49 is 7 plus 5. And we can see that this is clearly false. 12 is not equal to 2. Therefore, x equal 20 is not a solution. Let's next check x equal negative 4. Again, checking your original equation, which is the square root of 2x plus 9, plus the square root of x plus 5 is equal to 2. As we check x equal negative 4, we'll plug in everywhere that we see x. So under this first radical, we have the square root of 2 times negative 4 plus 9 plus the square root of a negative 4 plus 5. Is that going to give us 2? Under this first radical, we have a negative 8 plus 9, or 1. Underneath the second one, negative 4 plus 5 is 1 also, producing a 1 plus 1 on the left, and that indeed gives us a true statement. This statement is true, therefore, x equal negative 4 is a solution.